Hello, in this video, we start to recall and practice exponential functions. Before you jump into the assessment questions, let's together to review some of the most basic and important concepts and properties of exponential functions. First of all, exponential function definition says if b is a constant real number, the condition is b greater than 0 and not equal to 1, then for any real number x, a function of the form b to the x power is called exponential function of base b. So, in other words, the exponential function, the changing variable, recall, right? Before our function, the polynomial function, like we gave me, is always like something like this. The polynomial function, my base is the variable. The power exponent is the real number. But the exponential function, kind of other way around, is my base right here is the real number, but the the power, the exponent is variable. That's we call the exponential function. And the b, this base b has to greater than 0 and not equal 1. If you're equal 1, then doesn't matter what is my x value, but it's always equal 1, right? So, okay, then let's start using some example to get a little better idea about exponential functions, how they looks like. We go to the graph. First of all, give a very basic one. The base is 3 and 3 to the x by exponential function base is 3. In order to see the graph, like we pick up some point, help me, right? When I look at this, I already know they cannot be negative. Then I pick some point, give a little scratch. So let's show me, that's the function 3, base 3 to the x exponent function looks like. The next one, this one, compared to the first one, my exponent, right, the variable here on the power is negative x. Okay, so we still can plug some point in there, and also I write here, we can, thinking about algebra, this 2 to the negative x, we also can write as 1/2 to the power of x from our previous algebra exponent rules. So why is that? So I give you a little detail. That means 2 to the negative x power we can rewrite as -1 multiplied by x, right? And then I can write as -1 inside and outside is x power. Why? Because the exponent rule, I have a constant, right? A to the m power. Outside parentheses another power, so that'll be equal, keep the base, and multiply, and right? So let it both way go. So let's I follow this exponent rule, can rewrite this x to the negative power 2 to the -1. A -1 exponent, it just can write as 1 over x. So like in there. So before you plug in the number, if you can see it's equivalent to this, that'll be easier for you to get a graph. And in this case, we look at, oh, my graph is go another way. Okay, we can continue look at more style. The next example, we have more terms. The function is one constant term with a exponent function, and base is 2, but exponent is not a single variable, it's x plus 1. Again, we can plug some point, and also we can using the parent, the base function of 2 to the x power, using the transformation of function to get my graph. Okay, if I do transformation, we look at here, my changing variable is plus 1, right? And then we shift is plus 1, 2. Let's look at how do we using this basic parent function to get my graph. As we just the analysis, we rewrite this as negative 2x plus 1 plus 1. That means the whole graph of this negative 2x plus 1 will be shift 1 up. First of all, we transfer this one. Negative, that means from my basic, this one is the red color is 2x power. It's negative, so in other words, I reflect to x-axis, get this blue one. And then, and my x has a plus 1. Plus 1 means I shift 1 unit to the left. After flip this x, the right one, right? Then I switch to left 1 unit. And last, they go up 1 unit. From here, go up 1 unit. Here's a little bit summarize. You can look at it to relate it to the question we just talked about. No need to memorize this. Yeah, you just need to understand what this mean. Okay, and